So hi everyone, I welcome you all to this series of thermodynamics sessions, and in this session we will be going to discuss few things that are as follows. First we will be going to discuss second law of thermodynamics. Then we discuss efficiency of heat engine. Then we discuss Carnot engine, the most efficient engine. Okay, so let's start with second law of thermodynamics. So before going to second law of thermodynamics, we should know what is first law of thermodynamics, and we have already discussed what is first law of thermodynamics. And according to that, it means that energy can neither be created nor be destroyed, and it can convert from one form to another form. Therefore, why we this statement itself is sufficient to tell that there is a need of another law of thermodynamics, which will tell the direction of the process or whether the process is feasible or not. The first law is valid for any thermodynamic process, but we don't know whether the thermodynamic process is feasible or not. Means we don't know whether the thermodynamic process is spontaneous or non-spontaneous. Okay, so basically second law of thermodynamics tells us about the direction of the process. So if in case, let's say we are having a body that is at 100 degree centigrade, and you have connected the body with that is at 0 degree centigrade, then heat will flow from this body to this body. Okay, and this direction is because this is the natural law, and that is coming from the second law of thermodynamics, and this is a very spontaneous thing. So 100 to 0 degree is spontaneous, but if I say, let's say I am having 50 degree centigrade of body, and I am having attached another body that is of 50 degree centigrade, then there is no transfer of heat possible in a way that it will not going to 0 or it will not going to 100. So you have to understand that second law of thermodynamics is basically a natural artifact of the thermodynamics, which tell us about mainly the direction of the process, and in which direction process will go, and whether the process is possible or not, or whether the process is spontaneous or not non-spontaneous. And I think you have in chemistry you have more you have went deep into the that part of the process where you will get to know whether the process is spontaneous or non-spontaneous. Okay, so the statement of second law of thermodynamics is that all work can be converted into heat, but all heat cannot be converted into work, and that is second law of thermodynamics. So basically conversion of heat to work is possible through heat engine. Okay, so this is all about second law of thermodynamics, which will tell that work can be converted into heat, but heat cannot be converted into work. Now we will going to discuss heat engine. So in heat engine we are having a source. Let's say this is a source, and we are having this sink. Okay, and we are having heat engine. This is at Q1, this is Q2, and heat engine is extracting heat from the source and there is a sink as well, and in between the process there is a work done. So heat engine is converting heat into the work, and this work is nothing but Q1 minus Q2. Okay. So you have to understand that here it is Q1, it means that it is a temperature T1 and it is a temperature T2, therefore T1 is greater than T2. So source is always at higher temperature than sink, and then therefore there is a transfer of heat, and that is according to the second law of thermodynamics. And so there is a work done by the heat engine where it is extracting heat from the source and converting it into the work. Some amount of heat is not converted into the work, that is going into the sink, and that is the second law of thermodynamics as well. So basically when we have to find out the efficiency of heat engine, so efficiency of heat engine is the net work done divided by the heat supplied, so that is Q1. Okay. So efficiency of heat engine is net work converted by heat engine divided by net supply of heat. Okay. And therefore W is nothing but Q1 minus Q2 divided by Q1, and therefore it is 1 minus Q2 by Q1. So efficiency of heat engine is 1 minus Q2 by Q1. Okay. Now in case of when sink is not there, so we are considering that whatever the heat is extracting from the source is converted to the work. So in that case the efficiency is 100%, and that is the idealistic process. Therefore for that case when there is no sink and all heat is converted into work, then eta is, you put Q2 to be 0 and you will get 1, and that is 100% or 1. But this process is not possible as per second law of thermodynamics. Okay. So that is all about the efficiency of heat engine. Okay. So in heat engine how the processes happen. So we are having a piston, and a fluid inside the piston cylinder system, or I can make it so we are having a cylinder piston system with a working fluid. So we are having a fluid inside this, and that is a piston. So this piston is connected to a wheel that you want to move, or a shaft. Okay. So as soon as you supply heat to the piston, piston will go up and down, and due to that up and down the wheel will move, and that is how this piston, this heat engine work. So you supply heat to the piston cylinder system, and this piston cylinder system will rotate this shaft, and due to rotation of this shaft the engine works, and then you will have work where, and then it depends on you how you are going to use that work. Okay. So this is the process which tells that from which you will get a feel that how car engine works. So you have to ignite, and during ignition you are having some heat giving to the piston cylinder system, and then they are expanding, there is expansion, there is a compression, and due to that the wheel is moving, and so there is a heat absorption. And this, here we get work. Okay. So network is positive, and one complete cycle we called as cycle is called to be as one stroke. Okay. So one complete cycle is one stroke. If some engine has having four cycles, where you will see expansion then compression, then we can say that it's a 4-stroke engine. So that depends on the number of cycles a engine is performing, and therefore this is the way that how heat engine works. Okay. So this is about heat engine. Now let's move towards the one of the idealistic heat engine that we called as Carnot heat engine. So Carnot heat engine tells us that this is the engine that is designed, their cycles are designed in a way that it will going to give a maximum efficiency. Okay. So Carnot heat engine has having a maximum efficiency, maximum theoretical efficiency. It is not possible in reality, but it is the idealistic engine which tells that no engine can have an efficiency greater than Carnot heat engine, and that is another statement of second law of thermodynamics. Okay. So Carnot heat engine, the two things are there. So because it's a idealistic heat engine, so when we are having a piston cylinder system, so in that case when we are having a piston cylinder system, in that case the bottom wall is considered to be a perfectly conducting. So this wall is perfectly conducting, and these walls, all of these walls are perfectly insulating, so that there is no loss of heat. And the movement of piston is, there is no friction between the piston and the cylinder, and therefore the movement is frictionless. Okay. So this is one of the idealistic heat engine, and we have to calculate the we have to discuss this process, like what is there which makes it so ideal, what are the cycles involved in that, and I think and we have to find out the efficiency of the Carnot heat engine. For now I am telling you what is the efficiency of Carnot heat engine. So we have just calculated efficiency, that is 1 minus Q2 by Q1, but in case of Carnot it is 1 minus T2 by T1, and we will be going to derive that how we come to this expression. Okay, so I think we'll cover in next part of the lecture. Thank you for your kind attention.